Right. So today we'll be dealing with what we call the isotopes. Isotopes. Right. We'll be dealing with the isotopes. So this is the new term here in this grade. So this is what we'll be dealing with today. So I need you to form a groups of 5 or 6. Just there. Just form groups 5 or 6 so that we can get started. So right now that you have formed your groups, I need you to read on isotopes. In your groups, I need you to read on isotopes. I'm going to give you 7 minutes to read on isotopes. Here in my textbook, they're on page 16. I'm not sure if the books are the same, but can you please read on isotopes there? Right. Now that we have read on isotopes, I have this picture here with me. Now, the question is, are these isotopes or no? Are they? They are not. Any other take? They are isotopes. Why are you saying they are isotopes? Oh, okay. No, fine. So, these are in fact isotopes. Now, according to what we have read there, what are the isotopes? Is there anyone who can tell us the definition of the term isotopes? Right. Yes, you are correct. So, if we're talking about isotopes, we're talking about atoms that have what? The same number of protons but different number of what? Of neutrons. Now, for the fact that they have a different number of neutrons means they're going to have what? They're going to have the different number of the different mass number. So, yeah, that is what we refer to as the isotopes. Atoms with the same number of protons but different number of neutrons, which results in different number of mass or different mass number. Right? So that is what you need to be very much careful of and be aware of. Right? If you remember very well from our previous lessons, we talked about the atomic number. And we said the atomic number is what? That is the number of protons, yes. If I talk about the atomic number, that is what we talk about, what? The number of protons. We also talk of the mass number. That we refer to as what? The number of neutrons and protons combined. We refer to that as what? As the mass number. And we said, if you remember very well, just to show to you that these are in fact the isotopes. I mean, we're going to use that concept where we say A for the mass number is equal to it's Z for the number of protons, if you remember very well, or the atomic number, plus what's included here? The number of neutrons, which is abbreviated as this. Now, just to write, this is what the mass number. This here is the atomic number. Now, this here is what? The number of neutrons. Now, here in this picture, I have this for diagram 1. What is the mass number here? The mass number is 13. The mass number is diagram 1. The mass number is 13 is equal to the atomic number. The atomic number is the one which is below here, so it's 6 plus. Do we know the number of neutrons? No, we don't know. So we're going to say this is X. So what would be the X here? What would be the X value? Yes? What would be the X value? What would be the X value here? What would be the X value here? What the answer of this is going to be 7, right? It's going to what? 7. So our X is going to be what? 7. We move on, we are going to do diagram number 2 now. Our base number is 14 is equal to number of protons, it's still 6. Then because we don't know the number of neutrons, we are going to let that be x again. So now, what is our x there? What is our x here? Our x is 8. Our x is now 8. We move on to further to diagram number 3. What is the mass number here? The mass number in this case is 12, and the proton number, or the number of protons or atomic number, is what? It's 6. So without writing on the board, what's the number of neutrons there? Because I'm sure you've seen the procedure here. Number of neutrons here. Number of neutrons here. Number of neutrons here. We have the number being 12 now. What's the number of neutrons? So the number of neutrons in this case is 7. Let me just write here. So the number of neutrons is 6. Now, upon doing this, we can clearly see that the x values are different, and the x values are what we refer to as the number of neutrons that we're working out. So we can indeed see that these have the different number of neutrons, which in fact means that we can refer to these as what? The isotope, because the definition of isotope says those are the atoms that have the same number of protons but different number of neutrons, which is the case as well here. Right. So yes, I think this is quite easy to comprehend. I'm not sure if there is someone who doesn't understand, can raise your hand. You can raise your hand so that you can see if it can help you or not. This is what we did the last time, so it should be easy for you to do this. It shouldn't be a difficult thing to do because it's what we've done already. So yes. But the important thing to take home here is that we're now talking of isotopes. The key thing is to identify or see that the difference is that the number of neutrons is the same. The number of protons is the same, but the difference is the number of neutrons, which results in the mass number being different. Okay, right. So we will also encounter a situation where we are going to have the ones that have the same number of protons and neutrons. So that is what we refer to as, if the number of protons is different, those are simply atoms of different elements. If the number of protons is different, those are the atoms of different elements. So I have this handout here with me, which is all about isotopes. So that is what we are going to do. So we are going to read and we are going to explain this concept, right? Can you please come and take these handouts and distribute them? Right. Now we are reading on isotopes. The first sentence there says isotopes are atoms of the same element that contain the same number of protons but different number of neutrons. So they have the same atomic number but different mass number, as we have already said. So that is what is being said there. So it further takes on that atoms of different atomic numbers. By atoms of different atomic numbers, we mean number of protons. So if the atoms have different number of protons, that means they are simply the atoms of different elements. That is what I just said here. Now, if we talk about the periodic table that I gave you the last time, if you can check there, you've got the two numbers there in the periodic table. You've got the two numbers and then the symbol of each element. Now, these numbers are what you call the atomic number and as well as the average atomic mass. We are still going to talk about the average atomic mass. So those two numbers are the atomic number and the average atomic mass. Now, to further go on we have what we call the atomic mass, which is what the relative, in other words, it is the average of what we've done. So we are still going to go on to those concepts.